are doing the mixed review worksheet from the week of May 4th. If we're looking at this, how many moles of iron can be made from 6 moles of H2? So where is our X going to go?
Under the H.
6 moles is what we have of H2. Where is our question mark though?
Under the Fe.
Under the Fe. So there's my X moles. Moles is the unit I'm looking for. What do I do with that 6 moles of H2?
Good question. Put it over 1?
I'm going to end up putting it over 1, but I want to put together my map first. So that 6 moles is where I'm starting from. We're going to go from H2 to Fe. We're changing compounds here. In order to go from one compound to another, what do we use?
Coefficient.
Coefficients, very good. I'm going to write coefficients on top of that line as a guide. Okay? This tells me what type of conversion factors I need before I can come on. Then Damarian, you said that we need to put 6 moles over 1. That's absolutely right. But I'm going to put 6 moles of H2 over 1. Since we're changing compounds here, I want to keep track of what compounds I'm talking about. That makes sense?
Yeah.
All right, so I have moles of H2 on the top of the first line. What am I going to put on the bottom of the next line?
3H2.
Where'd you get that 3 from?
The second number, or it's the first number, but the second part of the problem.
Where we're coming from, it'll be on the bottom. That 3 came from the coefficients of H2. Okay. Where are we going to? What's the question actually asking us about?
Iron.
Yeah.
Say that again?
How many moles of iron?
How many moles of iron? So I need moles of iron on the top. In order to use those coefficients, I have to be in the unit of moles. If I'm not in moles, I need to change it to moles. Okay? What's the coefficient of iron?
2.
I'm going to put a 2 up there. So this is starting off basic. This is what we did a couple weeks ago, where we go from moles of one thing to moles of another. All right, so I'm starting from left to right. The moles of H2 cancel out. 6 moles is on top, so it's going to be times 2 because 2 is on top. And then we're going to divide it by 3 because it's on the bottom. So 6 times 2 divided by 3. What does that come out to be?
4.
4 is correct. So 4 moles of Fe. Okay, so did you follow that one? Because that one was probably the most basic of them. Because now we're getting into the harder ones. You good?
Yeah. Yes. Yes.
Awesome. Okay. Now this will be challenging. We have 3.29 to the 23rd atoms of potassium. Where am I going to put that information? Don't tell me over 1. I'm trying to make a chart first. What are we talking about here?
How many liters of hydrogen gas?
But atoms of what?
Potassium.
Potassium. So I'm going to put that underneath potassium. 0.29 times 10 to the 23rd. I have to do it slow because otherwise it doesn't register on my iPad. Okay. All right, so 3.29 times 10 to the 23rd atoms of potassium. I put that underneath potassium. What are they asking for? Damarian, you said this earlier.
Now this, the coefficient.
Not yet.
Oh, no.
This is the question actually asking.
Hydrogen gas.
Hydrogen gas, and we're looking for the unit liters. Right? All right.
Yeah.
Do I see grams in here anywhere?
No.
No. So do I need the molar mass on this one?
No.
No. Is it staying in the same compound or is it changing compounds?
Changing?
It's changing.
Yeah.
So if it's changing, it's going from here over to here. What do I have to use to do that?
Coefficients?
Yeah.
Coefficients. So I'm going to write the word coefficients above that line. That tells me what I have to do. Now, in order to use coefficients, what units does it have to be in?
Moles?
Moles. So I'm going to have moles on the left and moles of the right, because we're going from moles of the potassium over to moles of hydrogen. All right. Are we starting off with moles of potassium? What unit is that?
Atoms.
Atoms. So we have to get from atoms to moles before we can use the coefficients. What's the number for atoms, molecules, ions, and formula units?
3.
Did we forget? Don't forget.
Kind of forgot.
Screen.
Yeah, times 10, something like that. Yeah, there you go. I forgot that.
I need a better stylus. Times 10 to the 23rd. This is driving me insane. Will this one work better? Oh, no, that's fine. All right. Let's put it up with it. Atoms is equal to 1 mole. So I'm going to use that conversion factor to get me from atoms to moles. Now, on the right-hand side with the H2, we have liters there. What's the magic number for liters? Who remembers that?
God.
Isn't it something to the 24th?
Look on the screen. 22.4 is equal to 1 liter, or 22.4 liters is equal to 1 mole. All right, you guys remember these numbers now? Oh, it's been so long since we've used these numbers. Okay, we have our plan. We're going to go from atoms to moles with Avogadro's number. Then we're going to go from moles to moles using the coefficients. And then we're going to go from moles to liters using 22.4. Are you ready for this?
Yeah.
I love your enthusiasm. Okay, so what do I do with that first number, that 3.29?
Put it over
Yeah,
one.
put it over 1.
3.29 times 10 to the 23rd atoms over 1. And we're atoms of potassium here. Okay? Now I have atoms on the top. What do I put on the bottom of the next line?
Atoms and
Atoms.
potassium.
Atoms of potassium. What number goes with the atoms?
2.
What? There's 2 atoms in a mole?
Oh, no, sorry.
The 3.29. Wait,
6.02. Avogadro's number. Remember that?
Yeah.
6.02 times 10 to the 23rd atoms of potassium. Because we need to get from atoms to moles before we can use that coefficients. I noticed that one of you, I don't remember which, was trying to jump straight to the coefficients. We need to get it into the moles first. And that's atoms in 1 mole of potassium. Follow me?
Yeah.
Yeah, reluctantly, yeah. All right, so we have moles of K on top. I need to put that on the bottom of the next one, right?
Yeah.
Now that I'm in moles of K, I can get over to the moles of hydrogen by using the what?
Coefficient.
20.
Coefficient. So what's the coefficient of potassium?
2.
All right, where are we going to? What's the question actually asking about? What compound? Moles of
Hydrogen.
hydrogen. So moles of hydrogen. What's the coefficient of hydrogen?
1.
1. All right, so now we have moles of K that cancel out. We have 1 more, because now we're in moles of hydrogen. We need to get up to those liters. What number did we say at the very beginning that we needed to get from moles to liters?
What's that?
Convert diagram.
The 22.4.
That's 22.4. So if we have moles of H2 on the top, what do I put on the bottom?
A mole of H2.
So now we go to just regular 1 mole of H2. What am I going to do on top?
The
The
22.4.
22.4.
All right. I'm running out of room here. It's supposed to be 24. This is supposed to say here. Let me see if I can erase it and rewrite it. I don't know if I can do it any smaller, but I'm going to try. Liters of H2. Okay. So 22.4 liters of H2 go on the top. The moles of H2 cancel out, and we are left over with the unit they were asking about. Yay! Ready to put this in our calculator?
Yeah.
Yeah.
All right, let's put this in the calculator. We need to make sure if you're using your iPhone as a calculator, you need to turn to the side because you're going to need that EE or EXP button. 3.29 EE23 divided by 6.2 EE23. Then divide by 2 again. And then times 22.4.
23. Can you repeat that again?
3.29 EE23 divided by 6.02 EE23 divided by 2 times 22.4.
Okay.
Do you guys, what'd y'all get?
I got 6.12.
Okay. That's where I got the 6 liters from. Demarion, did you get that? Or did you have problems putting it into your calculator?
Yes, I got it.
Okay, awesome. All right, let's try another one because that is as hard as it's going to get. The only way it'd be harder is if we threw in a molar mass, which is what we're doing on this one. It's just got to take it step by step. So 12 moles of NaClO3. Where am I going to put those 12 moles at in our chart? We're going to draw the chart first.
Don't you put the X under the O2?
I got to put the X under the O2. Okay. What unit do I put with it?
Grams.
Grams. What do I do with that 12 moles?
Put it under the NaCl one and the O.
Okay. All right, so there's where I'm coming from and where I'm going to. We're changing compounds here. We're going from NaClO3 to O2, right? What are we going to use to do that? What am I going to write above that line?
Coefficient.
Very good. What unit am I going to have on either side of this line?
Moles.
Moles. Very good. On the left-hand side, when we are looking at the NaClO3, our 12 moles, is this already in moles or do we need to convert it over to moles?
It's already in there.
Okay, so I don't need anything for that. How about on the right-hand side with the O2? Do I need to convert that?
Yeah.
Yeah.
Yeah, because we got to go from moles to grams. Grams tells us we need to use what?
The molar mass?
Molar mass. So here's on the bottom here. So we have 2 times 16.0. It's 32 grams per mole, right?
Yeah.
So we're going to go from moles to moles using the coefficient, and then moles to grams using the molar mass. So what's our starting point?
The 12 over 1.
12.00 moles of the NaCl3 over 1. We're right here in our plan. We're going from moles of one to moles of another. What do we use?
Coefficient.
So what's the coefficient of NaCl3?
2.
2. I'm more confident. You got that right. 2 moles of NaCl3. Where are we going to?
Grams.
Grams.
Grams of what? What compound?
Oxygen. Oh,
We need to go to
2.
moles of oxygen first then. So what's the coefficient of oxygen?
3.
All right. We've changed compounds. On the top here we see O2, on the bottom we see NaCl3. We've changed compounds now. Now we can go from moles to grams of oxygen by using the more mass. So what do I put on the bottom of this last line?
Grams.
Whatever's on top needs to be on bottom. So if moles are on top, we need to put that on the bottom, right?
Yeah.
So it'd be 1 mole O2 on the bottom. So what do I do on the top then? I'm trying to get to grams.
32.0.
32.0 is correct. Right. That means we're ready to put it into a calculator because the top of the last line is the unit we're looking for. That means we're going to go from left to right. 12. 3 is on top, so it's going to be times 3 divided by 2 times 32.
I got 576.
Is that what you got, Demarion?
Yeah.
Awesome. Is this getting any better?
Yeah.
Yeah, slowly, but all right. Do you want me to do the next one, or do you want me to skip to 5? Do 4 or 5?
You could do 4.
Okay. 6 is grams to grams. Okay, so we can do 4. All right. How many molecules of hydrogen needed to react with 2 moles of nitrogen? So how am I going to set out my plan here? Where's my X? Where's my 2 going to go?
Your X goes under the hydrogen?
Very good. It will be molecules. Okay? Because that's the unit that they're asking for is molecules. React with 2 moles of nitrogen. What am I going to do with that?
Write that under the nitrogen. The 2 moles.
Okay. Are we changing compounds here?
Yeah.
Yeah, because we're going from nitrogen to hydrogen. Do I write above that line?
The coefficient.
And what are the end caps for that arrow? What unit?
Moles.
Moles.
Moles and moles, right? The nitrogen here, is that in moles already? Is our starting number in moles?
Yeah.
Yeah.
Yeah, so I don't have to do anything else with that. How about our final number? Is that in moles?
No.
No, that means we need another line here to go from moles to molecules. What number goes with molecules, atoms, ions, and formula units? Just discuss that.
Wait, can you repeat that?
What?
Can you repeat that?
What number goes with atoms, ions, molecules, and formula units?
Is it the 6.02?
It sure is 6.02 times 10 to the 23rd molecules equals 1 mole. Okay. So we have our plan set up now, right? Because now we can get from moles to moles and moles to molecules. So what do I do with that 2 moles?
Put it over 1.
So 2 moles of N2 goes over 1. We have moles of N2 on the top. What am I going to put on the bottom of the next one?
Moles.
Moles of N2. We're going from the left side to the right side, from the N2 to the H2. What do I use to do that?
The coefficient.
The coefficient. What's the coefficient of N2?
1.
So I'm going to put a 1 mole down here. Where am I going to? What is it asking about?
Moles of nitrogen.
Well, we're starting at moles of nitrogen. We're going to moles of hydrogen. So that's why moles of nitrogen are on the bottom. We're going to moles of hydrogen. So what's the coefficient of hydrogen?
3.
So 3 moles of H2 are on the top. Those get canceled. Now I'm in moles of H2 and I'm trying to get to molecules. I'm here and I need to get up here. All right, we have moles of H2 on the top. What do I put on the bottom of the next one?
Moles of H2.
Okay, so here's our conversion factor we're going to use for it. Well, what number goes with moles?
6.02.
With molecules, what does that equal?
1 mole.
1 mole. Then the 6.02 goes on top. All right, are we ready to put this into our calculator?
Yeah, I am.
All right. So 2 times 3, because it's on top, divide by 1 or do nothing, times 6.02 EE23.
I got 3.61 EE24.
Yay!
I got the same thing.
How smart do you guys feel right now?
Kinda.
Kinda smart? Okay, so what I'm going to do is I'm going to pause it and let you guys think through the next one. And then you guys can lead me through it, okay?
Okay.
All right, you two. You gotta tell me what you want me to do. Where am I going to put my X?
Under the SO2
SO2. What unit am I going to put with that?
liters.
Okay. All right. Will be produced from 55.0 liters of O2. Where am I going to put that information?
Under the O2. The O2.
I'm going to put 55.0 liters here. Am I changing compounds?
No.
No.
What information is given to me?
They had the 55.
55 of what?
O2.
O2. What are they asking about?
How many liters of SO2?
SO2. So I am changing. I'm going from O2 to SO2. Right?
Yeah.
Unit goes on the either side of this line.
Mole?
Moles. In order to use the coefficients, you have to have it in moles first. All right, so we go from moles of one to moles of another. What do I use to do that? To go from one to another. just said the word.
Coefficient.
Coefficient. All right, so let's look at those, what they gave us and what we're asking for. All right, so we're starting off with 55.0 liters. Is that moles?
No.
No. Can I get it to moles?
Yeah.
Yeah.
Yeah, what number do I use for that?
6.02.
That's molecules.
22.4.
22.4 is liters. All right. How about on the right-hand side with the SO2? Once we convert it over, what unit are they asking for?
Liters.
Liters. So I have to go from moles to liters. What number goes with liters?
The 22.4.
The 22.4 again. So we're going to use this number twice in the same question. You follow that?
Yeah.
Both of them have to do with liters. What do I do with that 55?
Put it over 1.
Over 1.
So 55.0 liters of O2 go over 1. I have liters on the top. What do I put on the bottom of the next one?
Liters of O2.
Liters.
What number goes with liters?
22.4.
22.
That was supposed to be a 22. All right, 22.4 liters. What goes on the top?
The 3. O2.
Well, look at your conversion factor. Right over here.
So 1.
1 mole. So 22.4 goes on the bottom. 1 mole of O2 will go on the top. You're right here on the lower left-hand corner of our plan. We went from liters to moles. Now we need to go from moles to moles. How do you go from moles to moles?
Coefficient.
Coefficient, okay. I have moles of O2 on the top. So what do I put on the bottom of the next one?
Moles of O2.
What's the coefficient of O2?
3.
30.
Okay. They're asking me to go to what compound?
SO2.
What's the coefficient of SO2?
2.
So now I have moles of O2 canceled out. Now for my final line, they've asked me to go to liters of SO2. So I'm right here in the lower right-hand corner. I need to get up to here to liters. What do I use for that?
22.4.
22.4. So I have moles of SO2 on the top. What do I put on the bottom the next one?
Moles of SO2.
What number goes with moles of SO2?
3.
Once we use the coefficient once, we never use it again. Okay? So look at your conversion factor. What number goes with moles? Up here in the
1.
corner. 1. What do we use to get to liters?
22.4.
22.4.
So 22.4 liters goes on top of SO2. So that means moles of SO2 cancel out. All right. Ready to put this in our calculator? It'll
Yeah.
be 55.0 divided by 22.4 times 2 divided by 3 times 22.4. And what you got?
I got 36.6 and then a 7 at the end.
Okay, so I'm running it up to 36.7 liters. Try another one by yourself again.
Sure.
Or is your brain about dead?
It's a little tired.
Okay, so do you... Hold on.
Yeah.
All right. So let's get our screen back up here again. All right, can you see my screen where it says 6, how many grams?
Yeah.
All right. All right, so how many grams of hydrogen? That's That's what I'm looking for. Where am I going to put that X?
Under the H2.
Under the H2, that's right. That's going to be grams there. Are produced if 120 grams of sodium are available. So where am I going to put that 120?
Under the 2Na.
Okay. Okay, so I'm going from 120 grams of sodium, and I'm being asked about how many grams of hydrogen. So we're going from sodium to hydrogen, changing compounds here. Do you see how we're changing compounds?
Yes.
So I'm going to put a long line there, a long arrow saying this is where I'm coming from, this is where I'm going to. What unit does that have to be in?
Moles.
I'm going to put moles on the left, and I'm going to put moles on the right. Because I'm saying I need to get from grams to moles of sodium and then moles to grams of hydrogen. What am I going to write on top of the horizontal line?
Coefficient.
The word coefficient will always go on top of that horizontal line. Because in order to do that, to go from one compound to another, you have to use those coefficients. That's the whole point of balancing chemical reactions. Now let's look at our units a little closer. When we look at sodium, when we look at Na, it says 120 grams underneath. Is that the unit I needed to get to coefficients? Or do I need to do a conversion?
A conversion.
We need to use a conversion because they gave it to us in grams, but we need it in moles to use those coefficients. So that means if we see the word gram or the letter G, what do we have to figure out? Gram should automatically make you think periodic table. Okay.
Okay.
Liters is 22.4. Atoms is 6.02 times 10 to the 23rd. Grams is always the periodic table. So when you look at the periodic table, you see that I circled it on the lower left-hand corner. It's 23. There's 23 grams in every mole of sodium. All right. Now, when we get to the other side, to hydrogen, they're asking us about grams. So we're going to go from moles to grams here. When we go from moles to grams, we see the letter G, we see the unit grams.
Okay.
What do we need to do in order to solve this one for the conversion factor?
Put.
See G, that automatically makes you think what?
Grams.
Grams. Grams, what do we have to do to figure out grams?
Put it over 1.
Not over 1, but we're looking for a conversion factor right now. Look on your screen. I'm circling it.
Hydrogen?
Hydrogen. I have 2 of them. So I need to do 2.1.01, 2.02. Okay, so there's my conversion factor, 2.02. Okay, you follow me?
Yeah.
Okay, so I have 120 grams as my starting point. What do I do with that number whenever I have a starting point?
Now you put it over 1.
Now I'm going to put it over 1. So 120 grams of Na go over 1. I have grams of Na on the top. What am I going to put on the bottom of the next line?
Grams of Na.
Okay. Now look at our conversion factor from our chart, from our plan. What number goes with grams?
2.02.
That's for hydrogen. We're in sodium still. We haven't changed compounds yet.
23.
23. So 23 grams goes on the bottom. Now is grams per what? What do I put on the other side of that line?
Mole.
So 1 mole of Na would be on top. The grams of Na will cancel out. We are now here in our plan in the lower left-hand corner. We're trying to get from moles of sodium over to moles of hydrogen. What do we do? What do we use to do that?
Coefficient.
The coefficient, that's right. So what's the coefficient of Na?
2.
So that means I'm going to put 2 moles of Na on the bottom because I want the moles of Na to cancel out. I'm trying to get to hydrogen, right?
Yeah.
I need to get to moles of hydrogen. So I have to use the coefficient of hydrogen. What would that be?
2.02.
That's the molar mass. We need to get to the moles first. I need to get the coefficients first. What's the coefficient of H2?
2.
Look on your screen, please.
1.
1. There you go. 1 mole of H2. Very good. And we're going from moles of H2 to grams of H2. Whatever's on top has to be on the bottom of the next one, right? So if I have moles on top, that means I need to put moles on the bottom. Look at your conversion factor now with your molar mass. What number goes with moles of H2?
1.
1. And what is that equal to?
2.02.
That's right, that'll be on top. The moles of H2 cancel now. Whew, this is a long one, right? Okay, so
Yeah.
now we have it in grams of H2 on the top. That's what we're looking for. Now we can put it into our calculator. 120. 23 is on the bottom, so we're going to divide by 23. 2 is on the bottom, so we're going to divide by 2. And then 2.02 is on the top, so we're going to multiply by 2.02. So it'll be 120 divided by 23 divided by 2 times 2.02. What did you get?
5.2. Well, I got 531 over 115. Put it in.
5.
Oh, what? 5.2695.
That's good enough.
Yeah.
Okay. Grams of H2. I'm not going to worry about sig figs at this point. I just want to make sure that you're able to do this part. Okay. How do you feel now?
A little bit better.
A little bit better?